This is proofs, page 1. How do we know that this expression, this equation with the left and right side is true for all values of x? So first thing they ask us to do is they want to test it by putting x equals 1 into all positions of x and see what we get. Okay, so we have 3 times -1, so that's -3. We have -4 times 8, which is -32. And then we have 2x, which would be just 2, and then -2. And then here we would have -7 times 5, which is -35. And we can add these up and we'll see that they are indeed equal. So yes, we showed that -35 equals -35, right? Then it says to do the same thing by making it equal to -2. So we're going to put -2 in all these positions. So we got 3 times -4, which is -12. 3 times -2 is -6, plus 5 is -1. -4 times -1 is +4. -2 times 2 is -4. And -2. And this one would be -2 plus 4 is 2 times -7 is -14. And we can see that that's also true. -14 equals -14. And then it says, if the proof holds true for 2 values of x, does this mean it will hold true for all values of x? And not necessarily. Okay, with math, just proving that at 2 values of x, the equation holds true only means that the left function and the right function might intersect at 2 different points, but not at all the other points. And you can think of a lot of functions that don't lie on top of each other that cross at 2 points, right? So, no. Okay. Now what we're going to do is we're going to do a demonstration where we put this left side and right side on a page with 2 columns. And what we're going to do is we're only going to touch the left side and we're not going to touch the right side. Okay? So let's do that. So we're going to copy this down here. So we'll have 3 times x minus 2 minus 4 times 3x plus 5 plus 2x minus 2 equals -7 times x plus 4. And what we're going to do is we're going to divide the page up into 2 halves. And we are only going to touch the left side, and we're going to try to make it look like the right side. Okay? Why are we doing this? Because lots of times in our class, the IB is going to ask you to show that this equation is true. And what they mean by show that is they want you to modify the left side algebraically until it reaches the same statement as the right side, but they don't want you to touch the right side at all. Okay? So, for example, in this case here, you can see that the right side is much more simple than the left side. It's only got basically one binomial multiplied by a coefficient. You can imagine that it's basically an x term and a constant term. We'll need to do some distributive property and combination of like terms so that we can get it to the right side, right? So we'll do that. So we'll distribute the 3 to the x and the 2. We'll distribute the -4 to the 3x and the 5. And then this we don't need to do anything to. And then we're going to combine the x terms together. So we got 3x minus 12x plus 2x, so that's -7x. And then we'll combine the -6, -20, and -2. That gives us -28. And then we don't have it quite looking like the right side. The right side has a -7 coefficient out front. How about if we factor out -7? And now we factor out negative 7, and it looks exactly like the right side. And now we could say QED, which means, oh, I proved what I set out to prove. Okay? You can read this about what QED means. Nice thing about Latin is it's very much like Portuguese, so doesn't sound so weird to you as to Americans. Let's see if there's any other notes that we want to make about this. Yeah, so we changed the left-hand side until we made it look like the right-hand side, and I think that's it. Okay, so that's the technique we're going to use whenever we see the phrase show that on the IB exam. Okay, important thing is you do not touch the right side, right? Okay. All right, so let's do it for this one. Same technique, we're going to distribute all the coefficients, and then we're going to combine like terms, and then maybe factor out a negative 2, and then we're going to see that we'll get what's on the right side, right? So we'll have negative 2a plus 4 plus 6a plus 18 minus 6a plus 30. Now we need to make it look like the right side. Basically, the right side has a variable term and it has a constant term with the negative 2 factored out. So let's combine our variable terms. Negative 2a plus 6a minus 6a gives us negative 2a. Combine our constant terms. 4 plus 18 plus 30 gives us 52. Is it 52? 4 plus 18 plus 30. Oh, I'm sorry, this should be 8. It should be 8, right? Sorry about that. 8 plus 18 plus 30 is 26, 56. So we have negative 2a plus 56. We need to factor out a negative 2 to make it look like that, and we end up with negative 2 times a minus 28, which is equal to what we tried to find out, right? QED. Okay, so that was it for the first page. Let's go to the second page. Now, all these examples here are just simple algebra problems. Probably most of the ones where you're going to do this are going to be mostly trig problems and sometimes log. Okay? All right. Show that x minus 3 squared plus 5 equals x squared minus 6x plus 14. Again, we only want to touch the left side. So let's see, we're going to expand this and convert it to standard form like here. Okay, so we're going to expand x minus 3 quantity squared. We know that we could do binomial expansion with that. So we have x squared minus 2 times 3 times x, which would be minus 6x. Negative 3 squared is positive 9 plus 5. And then we just combine these two. So we have x squared minus 6x plus 14. And it is equal to what we started out with. Okay. QED. Okay. For this next one here, this takes a little bit of thinking, right? If we're just going to modify the left side until we get the right side, let's look at the fractions on the right side. The fractions on the right side are not as different from this as you might think. If you look at this one especially, it's related to both this and this, right? Because m squared plus m, if you factor it, is equal to m times m plus 1, right? And even though we're not supposed to modify the right side, I'm studying the right side to see how I'm going to modify the left side, right? So the right side basically has 1 over m plus 1 plus 1 over m times m plus 1. So it looks like what I want to do is I want to change my left side so that it has a denominator of m over m plus 1, and somehow I'm going to get it to look like this. I can't really see exactly how to do that yet, but I can see how I can make the denominator m times n plus 1, right? What I could do is, and the only thing I'm allowed to do is I'm allowed to multiply the left side by 1, right? So I'm going to multiply it by 1, but the 1 is going to be basically a fraction with m plus 1 over n plus 1. So if I multiply the left side by this fraction, which is equivalent to 1, which I can do, I don't have to multiply both sides by 1. If I'm multiplying by 1, it doesn't change the value. Then I'm going to get m plus 1 on the numerator, and then in the denominator I'll have m times n plus 1, right? And then I could separate this into two fractions. I could divide the numerator into two separate fractions where the denominator is the same. And then I'm really getting close to what I have on the right side, right? Because now I could cancel this, and then I'll end up with 1 over m plus 1 plus, and then the bottom here I could combine with multiplication, and then I'll end up with 1 over m squared plus m. And so now I have exactly what's on the other side. Okay. QED. All right. What about 4a? Prove that this left side is equal to this right side. Okay, they might also say show that. Remember that if you have a fraction divided by a fraction, it's equal to multiplying by the inverse of the second fraction. So we could, instead of writing x minus 2 divided by x divided by 3x minus 6 over x squared minus x squared plus x, we could invert the second fraction and multiply. So then we end up with this, right? And then we're working with the left side only like we're supposed to, right? What about now? Looks like we might have a common factor here between these two, right? So if we rewrite this, the denominator here could be, we're going to factor out a 3, and then we'll end up with x minus 2 remaining. And then the x minus 2's cancel, right? Then we'll have x squared plus x divided by 3x. And then we're very close to having the right side now. Just have an x less on top and bottom. Look, we can factor x out of the top. And now the x's cancel. So now we have x plus 1 over 3. And we've proven what we wanted to, right? Just one thing to be careful of. For what values of x does this mathematical statement does not hold true? And what we need to be careful about here is if you have any x's in any of the beginning or intermediate or final expressions that are in the denominator, you have to be careful that the denominator never becomes x equals 0 in any of the expressions. Okay, so like what about the initial expression? Is there anything which would make this denominator, the denominator of either of these two, equal to 0? And yes, x equals 0 would make both fractions have a 0 denominator. So x cannot be 0, that's for sure. Okay, and what about any of the intermediate expressions? What about here? 3x minus 6 also should not be 0. Okay, and that means that x should not be 2 either. Okay, and then basically for this one too, x should not be 0, right? So I think that's it. So x should not be 0, and it should not be 2. All right, and I think that's it for these simple algebra problems. But just to show you the technique, where if the IB says show that, and they have a left side and a right side to the equation, you can modify the left side with any kind of algebraic technique you want until you get to the right side, and then once you find that it is equal to the right side, then you're done with the proof for the demonstration. and you may not touch the right side. Okay? It's like the right side is kind of like the correct answer or the correct simplification, and they're giving it to you so that you could do all the necessary steps on the left side and confirm that you're correct. Another reason why they do a show that problem and they kind of give you the answer is that by doing that, the next step, you can start with the answer even if you were unable to find the simplification which gave you the correct answer. Okay?